Some important points about the hyperconjugations. It is example, maybe you can learn this, by examples. What is the effect of hyperconjugation on the chemical structures? As in the hyperconjugation there is a pi bonds and sigma bonds. So there is a pi bonds and sigma bonds. I will explain this by, suppose this is showing hyperconjugation, this is a pi bonds, this is a having sigma bonds. I will explain the detailed structures. C H H H C. Now this structure having this type of structures, this is having pi bonds and sigma bonds. These pi bonds, sigma bonds are involved in the formation of hyperconjugation. So sometimes these pi bonds will come to these positions, so sometimes it become a, sometimes this become a double bond, sometimes this become a single bonds. So in this way this pi bonds has a character of single bonds and double bonds both. That's why this bonds, pi bonds, has a less length than the single bonds. Pi bonds has a less length than the single bonds, but this pi bonds has sometimes single bonds character and double bond character. That's why the bond length of this pi bonds increases, and this single bonds has a more length than the pi bonds, but this single bonds become sometimes pi bond. That's why this bond length sometimes decreases. So the bond length is affected by a hyperconjugation. What is the main difference between resonance and hyperconjugation? Is the resonance involve the pi orbital for the movement of decoalizations of electrons, but hyperconjugation involves sigma orbitals, usually C, H and CC bonds. CH bond are involved. This is a single bonds are involved. Sigma bonds are involved in the hyperconjugation, but for the resonance there is involvement of pi bonds, pi orbital are involved in the decoalizations of electrons. The number of no bond resonance structure due to hyperconjugation. So how many structures will be formed by the hyperconjugations? As there is a 3 hydrogens, so 3 hyperconjugating structure will be formed, plus 1 the aliphatic structures. 1 aliphatic structure means this is the 1 structures. After that 3 structure will be formed by the decoalization of these sigma bonds. 3 structure will be formed, 1 structure, 2 structure, 3 structure, 3 hydrogen, 3 structures, and 1 structure, this aliphatic structure. This is also considered as a number of hyperconjugating structures. In the number of hyperconjugating structures will be number of alpha hydrogens plus 1 equal to 4. Here is a 2 hydrogens, so 2 plus 1, 3 structures. This is a double bonds, has 3 hydrogens and 3 hydrogens, 6 hydrogens plus 1, 7 hyperconjugating structure. This carbocation has a 3 hydrogens, 3 hyperconjugating structures plus 1 equal to 4. This structure will also counted as a hyperconjugating structure. This is a 9 hydrogens, and this will be 1, 9 plus 1, 10 structure. In this way we can get to know the number of hyperconjugating structure. Greater the number of CH bond at the alpha carbon to the unsaturated system, greater will be the electron releasing, and thus greater the hyperconjugation effect. And the hyperconjugation effect means there is a 3 hydrogens, this is a 2 hydrogens, this is a 1 hydrogens, means as the hydrogens increases with respect to unsaturated system at a alpha positions. At the alpha positions the hydrogens increases, there is an increase in hyperconjugation. This increases the stability, this increases the electron releasing ability of this group, so it will increase the stability of a compounds. So this is shown in the upward side, this increases the stability. Now we learn some examples of hyperconjugation. By this example we will again much more clear the about the hyperconjugation. We will much more clear about the hyperconjugation by this example. There are some 7-8 examples are there in the hyperconjugation. By this we will be much clear about the hyperconjugation.